Hello and welcome back to our panel discussion on day 2 for SPARCS 18. It is my absolute pleasure to welcome our 5 speakers, as well as my friend Julie here, as we look into the deeper themes today around about, the applied behavioural genetics as it relates to companion and working dogs.
But before we get into the lovely people here, there's some beings behind us. These were some of our viewers through Twitter.
We have loved seeing everyone's watch parties, really enjoying not just the beautiful dogs and the characters that we're seeing, the sleeping cats that obviously find a canine conference incredibly exciting.
It happens.
But we really are enjoying all the photos that are being shared with us every day. So thank you everybody for forwarding those via Twitter. But before we go further, because it is day 2 and we may have people just tuning in for the first time, waking up in places like New Zealand and Australia now, we will introduce our lovely speakers. So starting from down on the end here, we have Dr. Kelly Ballantyne, who is board certified by the American College of Veterinary Behaviourists and is a clinical assistant professor at the University of Illinois College of Veterinary Medicine. Next to Kelly, we have Dr. Chris Irizarry, who is the director of the Applied Genomics Centre at the College of Veterinary Medicine at Western University of Health Sciences. And then we have Dr. Eleanor Carson, who we just heard from. She's an assistant professor at the University of Massachusetts Medical School and the Broad Institute of MIT and at Harvard.
And I would like to introduce Dr. Claire Wade, who is a professor of animal genetics at the University of Sydney and the chair of the Computational Biology and Animal Genetics. And to her left is Dr. Jessica Heckman, who is a postdoctoral associate at the Broad Institute of MIT and Harvard.
Now, I guess our first question, Claire, we're going to throw to you, and then we'll let you respond, and then if anyone else wants to chip in or chime in, we'll do that. But one of the questions we have is that you're trying to understand the genetics of behaviour, particularly looking at things like herding and retrieving behaviours that have been selected for in dogs over a really long period of time, even to the extent that people often just believe something like a good herding farm dog is just born knowing what to do and that there's no training required. So I guess we're curious, is this a logical starting point to try and unpick the genetic background for behaviours?
The belief that they're born that way and they don't need to be trained?
Well, starting with something that's been selected for over a really long point of time to that point that it's considered inherent.
I would say that you increase the risk of success if you start with a dog that has been selected from a family that's been selected for many, many generations to do a particular job. To pull one of Eleanor's mutts out and ask them to do that job might be a bit of a tall order, I suspect. I'm sure there's some in there that could probably do it, but it's less easy to predict that they might be able to do it without having other information that we don't yet have available to us. So I would say definitely selection has a big impact. Should that dog work out of the box, so to speak? No, I don't think so. And so then it becomes a question of the environment that dog's exposed to when it goes to the farm where it's working. Is it going to a farm where there are other experienced dogs there that can show it the way? Is it going to a handler who is an experienced dog trainer and if doesn't have other dogs there can actually teach that puppy how to obey the commands that are expected of it? Or is it just a person who doesn't appreciate that those things are required and expects that dog to perform immediately just given its inheritance? And I would say that's a little bit too much to ask of a dog.
I guess from the genetic perspective though, with a known behaviour like that or a known sequence of behaviours, and this comes back a little bit to the motor pattern stuff that we've touched on, is that a good place to start when you're looking to unpick the genetics behind what we're seeing?
It's worth trying. Again, as Eleanor showed, you need a bit of statistical power to do that. And at this point in our study, I don't believe that we have quite enough samples yet to attempt those questions. And we're hopeful of getting more so that we can. But at this time, I wouldn't feel confident about making a good prediction of major underlying gene effects based on observable behaviour differences in those dogs. But definitely the bottom-up approach, where we looked at the genetic selected differences between the dogs, definitely revealed to us a stop-go criterion that those dogs must pass in order to be a successful livestock herding dog. If they're living in the city and running in agility and doing obedience or just sitting on the couch at home, they don't really need that same requirement, that same ability to run on those hard surfaces and prickles and things. So that when the selection pressure comes off, the alleles that have not been selected start to resurface again. And actually it's an interesting point, because when I used to teach genetics to vet students and to animal science students, one of the things that we used to always teach people was that selection was a wonderful thing, because once you got it, it didn't go away. But what my research has shown me is actually it doesn't stick around. You've got to maintain it actively. And if you don't maintain it, then things start to revert back to like the status.
Dynamic nature of the
Yeah,
genes.
yeah, absolutely. So unless you maintain selection pressure, drift starts to begin again.
Any thoughts over here?
Other than my cough.
I was just going to add to that. First of all, thank you, Claire, because this is actually something that I've also had to kind of realize for myself as well, is that when we're studying working dogs, the action of ongoing selection is actually really important. That just because it happened 200 years ago, that's not the same thing as working with a population of dogs where every generation. And one of the things I'm quite interested in learning more about is, with each generation, what percentage of the dogs actually pass and which ones are taken out at that point, because that would be an interesting look at how strong the selection is that's actually acting on the population. But I think it also kind of points just once again at the complexity of all these traits and how we study them. But to get back to your original question, which is asking about whether studying the genetics of these behavioral traits in these populations makes sense, I think it's actually a really interesting question. I had somebody once that gave me the analogy of, well, isn't studying I don't remember what they were talking about, some trait in border collies, a little bit like studying the genetics of being good at math by looking only at MIT students, where everybody is good at it. So, you're really just comparing the ones that are good to the other ones that are really good, and maybe it's just environment after that. But I think actually, as I've learned more about how much variation there is in these working populations, I worry less about that, because it turns out that with each generation, there actually is a lot of variability in how well the dogs perform.
I just want to add the benefit of working within a relatively homogeneous population, but then teasing out the things that make the elite dogs different, is that the rest of the background is relatively quiet for you. So you get less noise in your analysis when you do that. So I had someone ask me actually just last weekend about the retrieving work. And they said, well, wouldn't you be better? Why are you comparing to the retrievers? Wouldn't you be better to compare to dogs that don't retrieve? And sure, you could do that, and you'd almost certainly see a difference, but you'd see a difference everywhere. You wouldn't just see a difference in the place that you were interested in. And so in order to filter out that noisy background, it's better for us, at least in the first instance, to concentrate on the area that's of precise interest to us. Later, we could go to something like Eleanor's data set and actually refine further to see which signals really pop out, so that, we take the signals that we think are kind of sort of good from our data, and then we'd go to something like Eleanor's data and ask them, do they retrieve a ball? And if they say no, well, we'd compare those dogs, and would expect to see a much stronger signal in the true areas of our inference.
Great, thank you.
I think it's also interesting that what you are aiming for and what you first think that you're looking for is not always what you find to be the most important trait. And so Claire, of course, told that story beautifully with, they're trying to find if dogs were better at herding, and found that dogs were better at walking on uncomfortable ground. And Eleanor and I were not as far along with our working dog project as Claire is, but when talking to guide dog groups, we're hearing very similar stories, that it's not hard to train the dogs to do the job of guiding a blind person. What is really hard to train them is to train them to do the job in the face of challenges, and so in the face of meeting a scary person or being in a new environment. And so for them, we sort of went to them thinking that we were going to be studying, the dog focusing on the human or something like that, or taking initiative. But what they're really interested in is focusing on the dog being able to overcome stress and fear. And so it seems like that story happens again and again, that you think you're looking at one thing and something else comes up.
One thing I'd like to add is that usually people who aren't involved in the working applications are the ones who are most adamant about believing that all members of the breed are equally capable of serving the working role. And the reason why there are sports that dogs participate in and that there's world champions and that there's people who get lines that come from that is a testament to the fact that not all members of the breed are equal. And the other part is the environment. I don't know offhand, I don't work, but how much does it cost to train like a seeing eye dog? I don't know.
Around about 50,000.
So if every dog could do it, why would you pay 50 grand? I mean, you could save a lot of money, you know? If you just took a dog out of a shelter that was that breed and not even train it, just send it on its way.
Well, some schools have done that. No, historically, I guess
But not even training.
it's been
Okay.
been shown that I guess over time there've been a lot of different ways of sourcing dogs for those kind of roles, and recruiting just through shelters was one way at one point.
But I mean, with no
But
training.
the efficiency's better if you have a selective breeding program.
Right, but I'm saying,
Yeah.
with if
Just grab a dog, put it in a harness, and
ju-
off you
ju-
go.
just give someone who's
Wait.
blind a random dog and say good luck. Yeah.
Probably not the best duty of care.
So one of the questions also was, how do we reconcile these early exhibitions of, let's say, breed-specific behavior with the ideas that early testing of behavior is not always predictive of later testing of behavior? So where does behavior begin?
You're welcome.
I don't actually have an answer for you, but we've been mulling over ways that we could do this by using some citizen science project where we put puppy videos online and get people to score them for us by like the thousands, because we figure people would really like watching puppy videos.
Because they're puppies.
Because they're puppies.
Okay.
And if it does have something to do with the way the sequence of behaviors that are used in play or something varies between different populations of dogs, you might actually see that, but only if you actually have data from enough
Right.
dogs. This basically comes from me realizing how hard it is to do behavior research and being like, how can we actually get the sample numbers up so we can say something?
Yeah.
But I think it actually is a really interesting question is, when do you start seeing differences that may be due to genetic differences manifesting in behavior, and how do they do
At
that?
what point does it become, you know, the younger dog become predictive of the adult?
Yeah, exactly. And is there variation in which traits are usable, like maybe there's some things you can tell in a really young dog, but other things that are not going to be. Yeah. I think I remember when we were talking to the people from Guiding Eyes for the Blind, they mentioned that some puppies just develop at different rates. And so if you do a test for a behavior at a particular age, there's some puppies that are just lagging behind a bit, but they'll actually get there.
It's certainly a belief, I guess, within the guide dog schools that I've been involved with, that when you have like an F1 lab golden retriever cross, the golden retrievers tend to be faster to grow in the body, but a bit slower to mature, I guess, in terms of the expectations you can have on them behaviourally and training.
That was a very
Compared to
nice way
the-
to say that.
Thank you. Compared to the pure labs. So that's interesting that you say that. Yeah.
Yeah, and one of the awkward things, Eleanor and I both have the same information pool to answer these questions, but
We do have a major disagreement, though, about the whole behavioral thing. It's actually quite interesting. We keep on coming back to this. You wanted a disagreement. This is a constant ongoing discussion we have.
Play it out.
Because
Go for it.
Let's workshop it, guys.
Eleanor's wrong.
clearly, you know what I think. So we have a project where we're looking at working dogs, and we're trying to understand whether we can identify genetic markers for which dogs are likely to be successful. And me not being a behavior person was like, well, let's just take the dogs that are completely terrible and fail out, and the dogs that are massively successful and really, really good at it, basically the two tails of the distribution, and compare those two groups. I still think this is going to work. But Jessica keeps on going on about how behavior is complicated, and you have to look at all this subtlety and these complicated scoring metrics. And scientifically, we're going to do both because that's the way it goes. But I'm kind of interested to see at the end of the day which of these approaches ends up working well.
Yeah, and she knows I'm right because she pays me a salary.
I just know I'm more right.
Because she pays you the salary.
I was just going to say, she has to write you a letter of recommendation for your next job.
Not if I work for her forever.
This is playing out well.
But to answer the original question, though, talking with Guiding Eyes for the Blind, so again, I haven't actually done my own research yet, right? I just talked to guide dog schools at this point. But they test at multiple points, and they find that the traits are the most heritable. So heritable meaning that they have the most influence of genetics rather than environment, when they test around sort of 12, 13 months.
And this is gauged by their estimated breeding values that
Right,
they've
exactly.
been using for multiple generations by now.
Exactly.
Yep.
However, I suspect that this varies by trait that you look at, right? So some traits are going to manifest more some are just puppy traits and are going to manifest more in puppies. But I think there is definitely something to be said for waiting for a dog to at least be close to adulthood. The other thing is that Guiding Eyes makes their decision and stops testing their dogs somewhere between 1 and 2 years of age. And so some of these traits may be much more heritable at 4 or 5 years of age, and they just aren't testing and looking at that. But they're definitely seeing that that 8-week test is useful, and they still do it, but it's not as powerful as some of the later ones.
I just wanted to put in livestock research using estimated breeding values. So for those who've just tuned in, estimated breeding values are, I guess, statistical metrics that describe an animal's propensity to be able to pass on desirable behaviours, but based on not just that animal's own capability, but also the capabilities of its family members, which they don't necessarily need to be the progeny, but they could be. It's better if you have some progeny, but at least close relatives of that animal need to be measured. And so we're looking for a family trend rather than an individual trend in that animal. And what they've found in livestock breeding is that even if you have the heritability, it's used in the calculation of the statistic, but at the end of the day, as long as the trait is heritable in some way, shape or means, the estimated breeding values will assist you to improve that trait, because actually in the calculation of the estimated breeding value, it presumes the heritability is 1 at some point. So it's actually set up presuming the heritability is 1 for the estimated breeding value.
And with some traits, do you find there's more weighting towards the maternal or paternal side?
That's not really been explored, but the one thing that people do ask about them, we have a group in Australia at the moment with working dogs who want to set up estimated breeding values for random bred working dogs, and the issue is that the use of estimated breeding values is kind of predicated on the use of purebred dogs or a single breeding population. It's not really well designed for use across different breeds, because then the use of estimated breeding values is presuming that you're working with the additive component of the inheritance, which is the allelic, the benefit of this allele versus that one. And if you have 2 of them, that's twice as good as having 1 of them. Whereas if you crossbreeds, then you get other non-additive genetic effects that come into play. So the effects of dominance and epistasis come into the way the genes interact. So the clicking, the nicking, if you like, of the genomes of the parental breeds comes into play, and which breed is the mother and which breed is the father is incredibly important. And so this sort of thing makes it much, much more complicated in that situation.
And then I guess also in terms of a project like yours, Eleanor, with the working dogs, you've also got the complication of if you're looking at pooling in data from different groups and populations, the fact that their behavioural assessment is probably done differently slightly everywhere. They're not using a unified behavioural assessment. So the scores that you're getting, the metrics that you're getting back about how successful a dog is going to be dependent on what characteristics are they scoring, what do they consider successful. Is it a dog that graduates from the training program and goes out? Is it a dog that graduates from the training program and doesn't come back within the first 12 months or doesn't come back within the first 3 years? Is it a dog that's successful, still working after 5 years of placement? Where do you gauge these things across different organisations to be able to do meaningful analysis?
I think it's a real issue.
I don't want to bring you down.
No, exactly. Well, the nice thing here is that I don't think there's actually a really good alternative, because
It's what you got.
Well, because if we focus on a single organization, even if it's a really big organization, something like Guiding Eyes for the Blind, there's just not enough individuals within that population to really tackle truly complex traits and pin down the variants that are responsible for those traits. And the idea here is really to find the specific changes in the DNA that are contributing to these behaviors, because then you could actually screen dogs, even dogs that you didn't know anything about, and actually score them based on their likelihood of being good at a particular job, which would actually be really cool. So instead, because we can't get enough dogs in a single population, we do have to, as much as possible, go to different organizations. And actually, I think, and hopefully Jessica agrees with me, that thus far we've actually been kind of we suspected there were similarities in terms of what the different organizations were looking for, even in very different kinds of working dogs. And that seems to have, even more than we'd expected, kind of played out, that they're all using maybe slightly different words for wanting very similar things often. And so I think there's always going to be noisiness in defining phenotypes. Even within an organization, you're going to have different people doing the scoring that are going to be thinking of different things. And hopefully by getting the number of organizations participating up, we'll be able to overcome a little bit of that.
I'd just like to say that I think in the instance of the use of guide dogs and customs dogs, there is a lot of genetic connectivity across the different organisations. They share size quite often across the organisations. So that as soon as you have genetic connectivity, it opens the door to allowing environmental comparisons. So you can then statistically correct for those differences in that system. But again, the more traits you ask to work with, the more likely you are to build in error. So it's probably better to start with something simpler rather than
I'm
something.
pretty sure she's agreeing with me right now about how you should just compare the tails of the distribution. I'm taking that away
No, it
from
only
that.
sounds that way.
I would just point out that when you go to the tails of the distribution, you don't have to worry where you put that line to create the dichotomy.
Totally agreeing with me too, right there.
So we think that working dogs always fail for exactly the same reason every time.
It's complicated.
All right, we have a truce.
I would say maybe not, but perhaps they succeed for the same reason every time.
We have 2 on 2.
And if we cut out the middle, that's where all of the ambiguity and the reasons and the complexity lies.
Yeah. See, if you don't look at the complicated thing, then it's easy.
Kelly, do you want to throw in the curveball of like the human element here? The fact that,
Wait. Let me
what about
ask.
the way the dogs are housed? What about the way they're reared? What about the handling and the training?
We
Like the
actually
effect
had
of that
questions.
outside of
Let me ask Kelly one question. Do you think behavior is complicated, Kelly?
Absolutely.
All right, and we're off.
Okay, so a question for you, Eleanor. Some physical and behavioural traits or phenotypes map onto one gene. Others have many contributing genetic factors. How do you go about determining which is which? So, for example, if I wanted to know about the genetics of a hairless breed of dog, how do you decide where to work that out? How do you decide whether to look if it's a 1-to-1 versus a many-to-1?
Yeah, no, I think it's a hard question. Hairless, 1-to-1. That's actually one we studied.
We know.
We saw that.
We kind of set it up.
I actually really like the hairless trait. It's a really interesting one. So when I first started in dog genetics, and I think Claire and I were probably working together at the time, we would talk to a lot of breed clubs, and they would tell us that traits were controlled by a single gene. And some of the time that was true. And generally the way you do that is you look at the pedigree and see whether it's inherited in a way that you would expect to be a single gene. So with something like hairless, where actually hairless is complicated because if you do get 2 copies of the mutation, then you're not born. We'll go to coat color. If you go something like white coat color, if you cross together a white boxer and a solid boxer, you know that you're expecting to get 25% white, 25% solid, and 50% half and half. And that's, did I get that wrong?
100% Tasha.
Oh, that's right. I meant to say if you cross 2 flash boxers, if you cross 2 heterozygous dogs, those are the proportions you'll get. Thank you, Claire. Anyway, so you basically look at the pedigree and see whether what you're expecting to see fits a single gene pattern. Unfortunately, we realized quite quickly that most of the time when people told us it was controlled by a single gene, that almost was never true, which ended up with a lot of studies. And the problem with this is that the number of dogs you need in your study is controlled by how complex the trait is, so how many genes are contributing. And so we'd set up a whole study design assuming it was this simple single gene thing, nothing would work, and then people would get upset at us. And we'd have to increase the study sample size and things like that. So I think it is a hard question, but these days, my default assumption going in is that things are much more complicated than we think it probably is based on just simple patterns of inheritance.
So one of the questions that came through to us was that, I guess in relation to the fact that most breeders of purpose-bred dogs are a great resource for behavioural observations of their dogs, and possibly there's no one better, but they're not geneticists. So how do you decide which breeders to rely on for your research? Or this comes a bit into the populations that you have access to, I guess. And do you have concern that breeders may be biased in their opinions of their own dogs, considering how much they have an emotional connection for and love them?
I'll approach that first. So in our Kelpie project, this is a problem that's commonly raised, is that people will bias the scores, they'll score their dog up, But at the end of the day, what we're really interested in is not that dog as an individual. We're interested in that family connectivity. And so for us, that dog is just a sample of that family. And so it's actually the family, the benefit of that family or the parental line that we're assessing when we're assessing that dog. And so presumably that dog will have litter mates elsewhere and will be in different homes. And if everyone sings the same tune, then we might believe it, right? But if we get a variation in the responses, then what we do is we take the average response for those to assess how good that animal might be. And we use the estimated, we plan to use the estimated breeding values model, which corrects for both the relatedness and the it can assess also the different environments, because if Joe Bloggs always rates his dogs extremely highly and they're all just fabulous and none of them are bad or mediocre, then we'd probably discount the scores from those dogs, because we know that that's probably an unrealistic relative explanation for those. That said, our latest study showed that most working dog handlers love their dogs very much, and there's definitely a skew in the distribution towards that top end. Definitely they're skewing up to the top scores for their dogs most of the time. So that kind of reduces the variability that we have to work with a little bit, unfortunately, but still.
Do you also, though, kind of have to go with the population you get access to? Like, I guess, with canine research in general, quite often researchers are limited to a little bit. There are some constraints on the questions we can ask depending on the populations we get access to study, particularly in relation to working dogs, because not every working dog program is going to be open to trying something different or implementing an intervention when they need to know that they're going to have a supply of working dogs coming through. They're not going to necessarily jeopardise changing the way they do things and risking that they may get a greater percentage of failure.
Yeah, well, we're getting a lot of pushback actually from particularly the let's say more mature breeders in the industry, because they're concerned that oftentimes their stud has a reputation for producing a particular kind of dog, and they're concerned that if they are graded quantitatively, that they will be revealed for not delivering what they promise, I guess. Well, maybe they believe they will, but they don't want to be compared, basically. And so that we're getting a lot of resistance to actually doing this quantitative comparison of different individual dogs from the breeders. Although I believe that is a phase that will pass as people become more comfortable with the idea of this resource being available. And I think in the next few stages, our goal is to mainly enable to give other breeders, not necessarily estimated breeding values, but to give other breeders a tool to identify other studs that have the same breeding goals that they do, so that they can then go there and choose a mate for their dog.
In my experience too, I found that quite often the practitioners on the ground or the people who are working with the dogs perhaps feel that researchers aren't always looking for the questions that they see as being most relevant. But by having a really good open dialogue and collaborating together and being able to, I guess, offer access to populations to get the questions that they would like answered done, and helping researchers see what's relevant to their work, I guess everyone can work together towards a common goal of improving outcomes for dogs and the people that they're helping as well, whether that's in a working role or as a companion animal.
Yeah, absolutely. That dialogue's essential. I think at the moment they're probably most frustrated with us because the progress is a lot slower than we would like. And that's partly because of technical issues relating to obtaining ethics for our survey forms, or having access to actual people on the ground who can actually help us to get the data in. And, it's really just a person power issue for the most part. But, yeah, I think a lot of these things are overcomable in the future.
So something to think about in terms of both working dogs and also companion animals is people look at maybe a trait that they see in their dog and they say, how come? Why are you like this? So when you look at something like noise sensitivity, what's genetic and what's early learning? What's early life experience, and how can we approach this really complicated
We touched
topic?
on this a little bit, but I think, yeah, it'd be nice to get broader input on this topic.
The only answer I have for you is that I can let you know in like 2 years.
Okay, we'll be back.
We'll be back, yeah.
See you in 2 years.
2020.
2020.
I mean, it's obviously complex, and there's interest in like startle response as like from a psychiatric perspective. I mean, there's dopamine-mediated phenotypes, and certain types of startle can be genetically encoded. I mean, I'm sure the panel is aware of what I'm going to say next, but I'm going to just say it for our viewers. The way I like to think about genetic selection is that let's just imagine that we have a population of rodents that are living in an environment, and this environment has, it's like a field, and there are predators that fly overhead, and these predators have really good eyes, and there's like tunnels and like hiding places around the perimeter, and then there's like just open spots in the middle. So just randomly, some of the rodents will probably have anxiety of being in open spaces, and some will probably have anxiety of being in closed spaces. So those that have anxiety of being in closed spaces will be in the open spaces and will get eaten, and what will be left behind are the ones that were able to survive through selection that had anxiety out and open, and so they hid. And then if you change the predator to like a snake that can get into the tunnels, you would see the opposite happen. So there's a time and a place for behavioral genetic traits to be selected. But other than that, I have no idea what's going on.
Well, I would just add that I think that there has been some work that looks at protecting against noise reactivity or trying to prevent that in the future. It's interesting, though, because, again, it's complicated, as everything is, right? So there's some studies that show that maybe exposing puppies to loud noises before 6 months of age seems to be protective against that. But then Dr. Emily Blackwell had a study not too long ago where she also showed that, yeah, it could be protective, but it was like dogs that were exposed to thunderstorms were maybe more comfortable with the sound of fireworks, but not thunderstorms when they were adults. So I don't know, it's muddy.
I think there's an interesting kind of follow-on question. So in terms of the genetics, in a couple of years, hopefully we'll have lots of genetic information from dogs that will also, their owners have told us about storm phobias and noise sensitivity and things like that. Using all of that data, we'll be able to tell you what percentage of a trait is controlled by genetics. So we'll be able to tell you storm phobia is 60% genetic. I have no idea what you do with that.
I was going to say, I think there's other research that links lateralization with noise sensitivity as well, which does suggest there's something, going on, at the biological level that's not just environmental, behavioral. There's something,
It's based entirely just on talking to people. I find that both the fact that a lot of people seem to think that storm phobia and noise phobia are not exactly the same thing is really interesting. And it's also one of those traits I think that people who live with an animal are going to know about. So it's something that we can ask people about.
And just a question where the answer might just be no, but might it, let's say you said it's 60%, right? Would that be across breeds, or would it be in one breed? Like this, this breed has this % chance and this breed doesn't.
Yeah, well, and it's not really telling you a chance, and that's why I said I don't know what
Yeah.
it means. It just kind of says that your likelihood of having this particular trait of noise phobia,
Right.
60% of the whatever risk it is that is contributing to that. That's a genetic something.
Predisposition.
Yeah, exactly. Predisposition.
right.
40% of it doesn't seem to have anything to do with your genetics. It could be anything after that. And Claire would probably actually do a much better job of explaining that statistic than I would. But it does tell you that it's not, like if something has zero genetic, zero heritability, then it's entirely environmental, and you can then focus on figuring out how to actually influence that environmentally, versus something that comes up as being extremely genetic, then you can know, well, we were trying to influence this environmentally, but we seem to be having a minimal impact. And so it is giving you that information. So something comes up as being 50% heritable, or 50%, kind of controlled by genetic factors, that tells you you've got another 50% to play with and figure out how to intervene.
Yeah.
One other thing to think about is maybe the application of that genetic knowledge can be used. For example, suppose just hypothetically that there's different levels of anxiety in puppies, and what you tap into is like a period in development where they might be more susceptible to being exposed to it and then have an adverse reaction. And so it's an environmental impact, but the underlying amount of anxiety associated with certain genetic alleles coming together might make certain puppies like better suited to have carefully controlled environments during early postnatal development compared to other dogs that might be more resilient to certain environments.
I'd just like to say that's a lovely idea, but that relies on people having early access to that genetic information. And that's something that's very challenging. You know, I'm working on, at the moment, I was telling Eleanor and Chris that I'm working on umbilical cord sampling, because at least that gives you the earliest possible capability of sampling a puppy so that you can get a result, but you're still going to have to wait a few weeks for that. So, you know, and then you have to analyse it and figure everything out. So it's not ever going to be, it's very unlikely unless you have a do-at-home test, which hopefully one day will be a possibility. I mean, I'd love to see that as a possibility, test at home.
There's an app for that. That'd be pretty cool. That'd be
Same
pretty
kind
cool.
of thing, but for genes. Yeah, but unless you have something that's available that early in an animal's life, you're really not going to get a benefit from it, I don't think. Unless you know the parents and the probabilities, and you can tell something from the, you know, from the behaviour of the puppies that triggers you to know what genotype it is. You still don't know precisely.
You could just have high risk and low risk sublineages, if you will, and then you just know, like, if your dog is one of the low risk ones, that you can act a certain way during development. I think ultimately, I think genetics is going to play into not so much what dogs are valuable or which dogs are no good, but they're going to inform genetics plus environment equals phenotype. It's really not, it's not so much the genetics that we're trying to change as much as we want to create the most optimal environment for each dog so we can get the convergence of a variety of genotypes to reach the ideal phenotype. And that's really the name of the game from my
And
perspective.
absolutely, that's what my research is entirely focused on, is trying to put the right puppy in the right home.
Which leads us on very nicely to the next question that came through, which is from Twitter, which was asking, how close are we to assessing the genetic markers for personality traits in dogs rather than just behavioural disorders?
Very, very far, because we can't do the behavioral disorders yet, so.
That's funny. We were actually, I saw this come through on Twitter, and so I was talking with Kelly about it, and I said, oh, Eleanor will answer this, and she'll say it's much sooner than I will say.
So Eleanor, is it like 1,000 years out, are we?
No, it's not that long. Things change fast. This is a field that's only like 20 years old. So, I think one of the things that I've tried to get my head around that I find really intriguing is that the challenge of predicting traits and predicting diseases is much, much harder than just finding the markers in the genome that are connected to them. And this has been actually shown over and over again in human medicine. So 10 years ago, if you read the human disease, kind of the human medical research literature, there was a lot of talk about using genetic tests to predict risk of things. And they're getting there now. There's actually some really nice work they've done with heart disease now, where they've done studies with hundreds and hundreds of thousands of people, and they can now actually do a pretty good job, and hopefully this will be moving into the medical world soon, of identifying people at an earlier age who are at a very high risk of having cardiovascular disease. And they've actually shown that people that are at that very high risk who adopt a healthy lifestyle can then actually end up with a normal risk level. So not only is it a genetic test that can predict your risk of getting disease, but it is one that actually has an intervention that would be useful at that time point. On the other hand, people have a very hard time following through on health advice, so that's a whole different behavioral issue that genetics can't help with. Just because you tell people they should do something doesn't necessarily mean they're going to do it. But that's kind of the first time we've gotten there with any kind of really complex disease, and it's been a huge amount of work to get there. So it's the good news is it's completely doable, and it should be easier with some of the behavior and personality stuff potentially in dogs than it is in people, just because of the history of selection on the traits. But I think people need to be really careful when they're interpreting the work that people like us are doing, and we come out and we say, we found a change in a gene that's related to a personality trait or a behavior. That doesn't mean we can actually predict that in a dog that we don't know anything about.
Yeah, and I think you wanted the microphone after I am done. Yeah.
Mm-hmm.
And what I wanted to say is that I think with the technology that we have right now, we're not that close to it, but genomic technology is changing so incredibly rapidly. And so when we were talking just now about the possibility of having a bedside test for a newborn puppy. I mean, we're starting to see that coming in the next couple, maybe less than 10 years, right? We already have a very small sequencer. It doesn't do a great job. And it's pretty expensive for each run, but we are starting to see the possibility of being able to just put a drop of blood into, have like a snap test type thing. So we're seeing that coming, and I think that the problem of untangling behavioral genetics, right now we don't see what the problem is. And so Eleanor had this beautiful picture in her talk with this almost sort of globe of connections of different genes interacting with each other. And we can't piece that apart right now. It's all so complicated. And Claire was talking about how what we're very good at looking at right now is just this additive. Like if each little allele, if each marker that we find just adds on a little bit of risk, we're good at understanding that. But there's this massive amount going on that is not that, that we just don't have the ability to really assess well at this point. And I think that a couple of things are going to happen. I think our computational power is going to increase, as it has continued to do for so many decades, and that's going to make us have the power to start attacking those problems in ways that we haven't yet. And I think also that the genomics, we're finding so many new ways of asking questions that we didn't have before, and we're starting to understand the biology so much better. And I think 10 or 20 years from now, we'll be designing entirely different studies than the studies that Eleanor and I are doing right now. And those studies will give us, I'm really hopeful that one of those things will get us over this hump, and we'll be able to answer these questions so much better that we aren't quite there yet.
I was just going to say it's like the stock market problem where, past performance is not a predictor of future performance.
We just had a comment come in.
That's exactly it, yeah.
Sorry, we just had a comment come in via Twitter.
Kelly had something to say.
This will probably allow you to still keep.
Please.
It's just a contribution. I'm going to get Julie to say it
Okay,
because I'm
and
going to
here we
cough.
go. So some people in the field say that a behavior, some people in the field say that a behavior is 20% genetic and 80% environment. What are your thoughts? But also say what you were going to say. Yeah, just let that float around.
Okay. Well, what I was going to bounce off of what Jessica said, and actually a conversation that we had earlier about this issue as well, is that not only are the genetics of behavior so complex, but we're also not really clear a lot of times in what we're describing. So if we're trying to assess personality traits or even specific behaviors, like Eleanor, you were just saying, well, what's the difference between a noise phobia and a thunderstorm phobia? We got to get a lot clearer about what we're describing in behavioral terms in order to help move this along, and that's also going to take a lot of time.
Right. And what is also consistent over time.
Right.
And what's just a
And the dynamic aspects that we touched on yesterday, things like diet and gestational environment and all those other influences and effects as well that sort of add to the realization of the genetic potential.
I just want to say that, probably in the 1970s, the idea of sequencing a genome was just very, very complicated. And, unless you take that step and try, nothing will change. So the motto at our university is, unless you change, nothing changes. And so we have to take that first step. And as imperfect as those first steps are, unless we do that, we will still be in the same place in 10 years' time. If we do take these steps, as Eleanor's group and my group and Chris's group are doing, then yes, we're going to make mistakes. And yes, it's not going to be the whole answer, but piece by piece, we will get there.
Make progress.
Yeah, we'll make progress. And so I think what I would urge is for people to feel optimistic because we have new tools, we have energy, we have cooperation, we have each other, and we have, a wonderful way forward.
Can I just follow up quickly?
Quickly.
All right, really quick. I was just going to say that complexity in genetics means that there's pathways of multiple ways to get something. So a quick metaphor you might consider would be you have a car, and the question is how long does it take for the car to break? That might be what factors in the genome are affecting a behavior. And then you have like environment. Is it raining? Is it snowing? How good are your brakes? Are your tires bald? Are you going downhill? What's your starting speed? So all of those factors coming in, there's not always just one single answer that says, oh yeah, that car has perfect tires. It could brake right like this. It's context dependent.
I don't need it. I was going to take it, but then I remembered I've got one built in. Thank you. Well, we have had another fantastic panel discussion that has flown by. The good news is we've still got some great questions to bring into tomorrow's final panel discussion after we hear from both Kelly and Jessica.
Tomorrow.
Exactly. So we will say goodbye for day 2 at SPARCS now.
And we'll see you tomorrow at 9:30 Eastern Daylight Time.
Thank you very much for joining us today. Bye.
Thanks.